Okay, so here we want the equation of the tangent line. And we know that this is the point that we want to contain. We just need the slope, so we have to find the derivative. So let's find dy dx. So let's see here. The derivative of this is going to be 2/3 x to the negative 1/3 plus, and then the derivative here, well, you go that times that. There's a 1 here, so that times that is 2/3 y, and then you subtract 1 from that, that's negative 1/3, which is what we did over there. But here, since it's the derivative of y, and we're doing implicit differentiation, dy dx, here you multiply by dy dx equals, and the derivative of 5 is going to be 0. Now look, let me tell you this. In most cases, you would have to do things where you get dy dx alone, and whatever you get here, some gibberish, that would be the answer. But notice that the goal for this problem is not to get dy dx alone. The goal for this problem is to come up with the equation of a tangent line. So what I'm saying is we really don't have to clean this up. You can if you want to. You can get dy dx alone by moving this piece to this side and then dividing by all of this gibberish. But you know what's actually better? This 8 is x, and this 1 is y. We can take this 8 and plug it in for x here. You can take this 1 and plug it in for y here, and then you'll see what happens. So let's see. You can type this into a calculator if you want. It should be this. Can you do this by hand? Yeah, but I think it's okay. I'm pretty sure your teacher will be okay if you just type this into your calculators. The cubic root of 8 is 2, but its negative would be 1/2. 1/2 times 2/3. The 2 is not, it's just 1/3. And then 1 to that is just 1. 1 times that is that. So this is what you should get. And now why don't we subtract the 1/3 to this side? So it'll be 2/3 dy dx equals negative 1/3. And then we multiply both sides by the reciprocal, which is 3/2. Gone. So the slope, dy dx, if you will, the slope of the tangent line at this location with respect to this curve is going to be, it looks like it's going to be negative 1/2. So that is our slope m. So now let's just go like algebra 1, if you will, and we can go to point slope. Y minus y1 equals m times x minus x1, where m is the slope, right there, and then your x1 and y1 are the original coordinates from the point given. So we have y minus 1 equals m times x minus x1. Technically, this is the answer. This is the equation of the tangent line, but in most cases, they prefer slope-intercept form. So let's distribute the negative 1/2. So negative 1/2 x plus 4. So final answer, y equals negative 1/2 x plus 5.